Yes, we are live. So, what are we discussing today? We can discuss the tumbler charger. Let me share the screen. I found this magnetic.
Magnetics.
Uh,
I put in a couple of links from the stream already.
yeah, so the tumbler is basically already has the USB charger, and the battery has some lithium-ion charger inside. So it just needs, I think, two wires to charge it. So basically, we could have this sort of magnetic stuff to charge
Yeah, but
the tumbler. So
it's still not enough.
why not?
How accurate does the movement of the bot need to be? If you have that sticking out and you have the bot and they are 1 inch apart, it's not going to work. In order for a magnetic thing to work, you have to have some sort of flexible element, which is, how should I say, less rigid than the force of the magnet. This is good if you're like, 2 millimeters away.
I think that'll actually be enough precision. Like I was thinking about air-to-air refueling, and we can apply that logic here. I think this cable is flexible enough. What it needs is kind of like targeting things. So one way to do that is to have a little LED or a laser pointer type device, and then you use a camera, and when the laser pointer is pointing at the other side in roughly the right point, you move forward and it'll connect. Like if I use my MagSafe connector on my Mac, it can pull from a fairly wide range. So if these are like neodymium magnets, I think it'll be much more than 2 millimeter. It'll be more like 4 or 5 millimeters axially and about 5 6 millimeters either side.
Yeah,
Or
but what is the
like one way
mechanical
to,
side?
We can try it. Yeah.
Side.
I was just saying that if we use a 3-pin uh, connector, so one of the like cables could be a proper connection signal, right? If it's properly connected, then like the charging starts. Otherwise, it's not the charging power is not on. Something like that could be done with 3-pin magnetic.
What are how many lines are there in USB C? And I guess 2 pins would be VCC and ground, right? And third pin would be
Uh,
connecting. What else is there?
so I'm now not thinking of the USB-C power delivery right now. I'm just thinking of making first a docking station just for the tumbler, for the battery the tumbler has already. So it charges
Hmm.
with USB, old USB A,
Hmm.
and then it has a micro USB on the battery, and the battery itself probably has some lithium ion charger inside. So we just need to connect 5 volt
Okay.
plus minus. Yeah, that's it. So the one of the if we can like push in, so you get these male female USB A connectors. So similar to the USB A connector we have for the ESPI, we could make a small board which has like a male here, and then the charging dock has a female USB. So we
Hmm.
just have to push in the USB connector inside.
And what is that
But
magnetic thing you're showing? That would just be sort of like a adapter
so we
on
don't,
top of
yeah, we don't
USB-A.
need the magnetic if we are doing trying to push in the USB A. So which
So
is easier, I
That's
don't know.
I,
I think magnet would be
I have
easier.
trouble doing it.
If you have to actually exert force, that other link you shared, I pasted the link in there. It has the specs. So the extraction force is what is it? 8 to 20 newtons. So 1.8 to 4.5 pound force. That's quite a lot. And mechanical
But
grippers are bad at that level of force, I think. But you could do this with if you use the whole body of the robot to push and pull. So if you had like a
But
rigid,
on
what?
you have to be exactly aligned.
That part, there's like, that's a design challenge, but you can do things like with, I mean, it's
But that's what we're
the
talking about.
magnet
How do
stuff.
we do
Okay,
that?
magnet, it'll pull in by itself within a fairly good range. For
Right.
mechanical, I would try to design like a funnel type thing with a flexible one on the other end, stiff but flexible on the pushing side, so it can get directed in the funnel. The hard part would be generating the pushing force, not the alignment, I think. Yeah, alignment, I can think of like a couple of different ways to solve it, including just trial and error, like write some software to keep, you know, pushing and pulling till it fits. But exerting that
Uh,
much force is hard.
I was thinking like, could this audio jack be used because it has like the it has like three lines, and then you could use like two of them for 5 plus 5, and the third one for like some sort of signal or communication. But I don't know if it's easier to push in the USB or like the audio jack.
I'm,
Yeah,
I'm,
this is, I guess, a query to ChatGPT, the extraction and insertion force for common connector types, microphone jack, USB A.
I really think that you should make a magnetic adapter element that you plug into the mini USB and then you charge using the magnetic adapter. These connectors, I don't know how good robots are, but I'm assuming they're not as good as a human. And a lot of these connectors are very fidgety.
So the
You
thing
have
about a
to have
magnetic thing though is you need a specialized dock on the other end. And the interesting
yeah,
thing about using a generic USB A is, in theory, you can go plug yourself into any available USB A socket. That's kind of a fun generality.
But
I'm
we
not
don't need like it to be like USB C or USB A, right? We could create like a jaw-like mechanism and like a tongue and jaw-like mechanism, and then we could just spread out the lines we need, 4 or 10 or whatever, and then make large pads out of
right.
it. And then basically, like the jaw, when the tongue is inside, the jaw just bites. Uh,
Yeah, if you're willing to design the other end of the connector, the options open up quite a lot. And there, I think, yeah,
No,
wireless
we
charging is
definitely
probably the
can.
easiest.
The flat connectors that are only a thin piece of PCB board with wires on it that you just push in without the grounding part on the outside. But I don't know about your house, but in my house, each USB socket, let's call it, is completely different. Different height, different angle. Definitely not at the height of a tumbler on the ground.
Oh, yeah, you'd absolutely need some constraints and stuff. So it's worth thinking of at least some sort of manipulator arm to have a little bit of a range.
so I posted this in the channel. So this is like a mini SG90 jaw mechanism, 3D printed completely. So it bites into stuff.
Yeah, I've seen things like this on Amazon that you can just buy for a few bucks. Very simple jaw mechanisms. The trick will be to get it low power enough, and
So
but my
it's a
guess is none of these will be strong enough to exert 1.8 to 4.5 kgf. So we'll either need a lower contact force connector or use the whole robot to pull and push.
No, but if you are using a larger servo, they have like quite a good like torque force, right? For example, this one, 30 kilo servo bus.
You're comparing torque to linear insertion force, so it depends on the lever arm, right? So 30 kgf Newton meter over like a very small length will not have much leverage. So we'll have to, yeah,
Okay.
yeah. But
Yeah, but
that's a
you're
calculation
applying
to be
it
done.
against the tumbler. Yeah. Okay.
The
So
reason
this.
I'm concerned about the force is I read that article on Substack that we shared a few weeks ago about how grippers to hold objects are actually one of the weakest parts of humanoid robots. They can't exert as much grip force as humans. And I think even at humanoid size, the maximum they can carry is like 10 kg or something, or 10 pounds. So fairly low weight.
No, but you get this USB A. Yeah, for you can have this USB A that just doesn't have the entire housing, but it just goes into the socket.
Yeah, I've seen this. I used to have this for
Us.
my Whoop charger. The force is about the same as a USB-A, even though it's a
Alignment
thin,
easier.
yeah, it's thinner, but it has about the same force. The thing is, I think the force is determined by the standard on the contact pressure, because if the contact pressure isn't high enough, the electrical connection will be weak. So there's a trade-off there.
Okay, I just found the link on YouTube. DeepMind's robot inserts a USB stick from 5 years ago.
Uh, where is the link? Can you share that?
No, I'll share it. So here's this one. And MIT also made something.
We're watching some ad.
Well, if you're not logged into YouTube, YouTube will push ads aggressively. Like you cannot basically, if you're learning, watching a tutorial, basically you will have to be logged in because the ad push is so aggressive now that you will be frustrated. Like it will be there every 2 3 minutes.
Right. And I also gave you a link to Discover magazine from 10 years ago. I really don't think USB was designed for humans.
But this is like old OpenAI stuff, right?
Yeah, but the point is, they managed to do it, meaning it's really, really not easy.
No, but look at the arm, right? We don't have that. So basically, we are restricted with our small robot. So what can we do with the small robot? That is the question, right? I was initially thinking of using that small lay robot as a in like you don't have to have anything on the tumbler itself, but the lay robot is just like the arm just grabs the robot and pushes it in. But I don't know if even that is strong enough for like pushing USB inside.
I think when you talk about pushing, it's a tumbler. It has to push, but the tumbler itself has to resist being,
Yeah,
moved back.
I was about to point that out because the other spec document that I think one of you posted, it says that the contact force for a USB is strong enough to dangle an iPhone. So an iPhone is, I think, about 1 pound at least. So you can like vertically dangle it. Yeah, that, yeah,
So in any case, it has to be the connector itself. In other words, you can't have a separate robotic arm. That'd be very sophisticated. And it's also
yeah,
a very
yeah,
straightforward problem. That's why maybe if you
That's
had
why
a standard,
all these robots have this sort of charging docks.
yeah.
So basically, they drive into it. But
yeah.
I
So
don't know
that's
how much
induction
power can.
charging, and it'll be slow, but it'll do the job. Like electric toothbrush, lots of things use it. So induction charging is the easiest solution here.
I'm wondering if you could have a standalone component which sits on the socket and plugs itself in.
Uh,
Maybe
so
using
there are
suction.
these USB-C magnetic. Uh,
What's that?
so it will look something like this. So it has like male female parts, and the connection itself is magnetic.
Yeah, so
Yeah.
that's an adapter. That's great, but you have to have one on each USB in your house.
It's still a start. I think I prefer my order of preference right now is wireless charging number one, magnetic number two, and mechanical force number three. The other advantage of magnetic is I think the alignment problem will be easier with magnetic because the last few millimeters it will take care of itself.
Yeah, but I'm skeptical about how easy it is to do the alignment to the accuracy of 2 millimeters. You're optimistic, and I'm skeptical.
If a human is driving it, I'm optimistic. So if you have like something like a laser or even a camera, laser would be best. It would be easy, I think, if a
Well, but
human is driving. If you had to drive, if you needed an autonomous algorithm, it would be a little harder.
So you
even if
could
you
have
do
some
it,
sort.
sorry.
You could have some sort of fiducials to align while. So basically, some sort of markers
Yeah,
the robot tries to find and then tries to talk and gets as close as possible, and then the magnet does the rest of the job.
yeah. There's many of the small robot kits. One of the experiments they include is a line following module, right? Like you can draw little white paint lines, and
Right,
a
right.
floor watching sensor will follow it. And that's very similar to how airplanes are guided to the gate, because airplanes also have like very wide turning radius and big wings, so they have to very carefully follow that line. So we can use that strategy for approaching the
Yeah.
landing.
So we could. So basically, the so I have not added it yet, but like we could. So the tumbler already comes for some with some sort of IR sensors on the
Yeah,
corners.
Hmm.
So we could have something like that that looks on the floor, and
yeah,
when it's like around the charging area, it could follow a path to the charging dock, and then when it's close by, the magnet just sticks together. So something
yeah,
like that could be quite easily
yeah,
done.
We
yeah,
could also have USB plug, which is thin, so it's very easy to push in, and then we expand it so it locks in place. That's not super duper reliable, but it could be, good enough for the robot, and it solves the problem of pushing force.
So YubiKey have these sort of constructions. You know, you what is YubiKey?
yeah,
YubiKey, yeah. So YubiKey, if you have like one of those, so they have this thin USB A. I think the images are better.
I don't see
So
that they
basic,
can't. These still
so they
require force to put in order to have a good connector.
yeah. The force is going to be the same. That just makes it thinner.
No, but what I'm saying is that imagine that the black plastic part is half the thickness, but when you put it in, it puffs up in order to push your metal contacts against the metal contacts.
Yeah, so
you could have some sort of like bubble
Yeah,
inflation mechanism, right? Yeah.
exactly.
that's way too complex. I would just the simple way to do this would be to have like thin flexible metal that's like pre-stressed and spring loaded a little bit, and it'll snap into place, and then it gets pulled out. I think that's how the standard connector is designed. You would just like make weaker spring force and more flexible metal, because the if you look at the diagram of the basic standard, there's actually side spring contact type things.
Right.
So you would just make that puffier, to use you guys' language, but I wouldn't try to put balloons and things here. I mean,
No, it wouldn't actually be a balloon. The two options that come to mind are one, using something like a shape memory alloy and heating it up in order to make it expand. And two, it would be like a wedge that you put of plastics that you push into a slot, and that when you push it in, it thickens the plastic. I personally prefer the shape memory because because you don't have any mechanical forces applied by the robot. You just stick it in, you heat it up, it expands and gets contact. You need power, of course, to do that. Yeah, if the robot gets to the connector with the last gasp, that's it.
yeah, that's why I prefer passive mechanisms uh, mostly. So passive spring force, snap contacts, things like that. Uh, Magnetic, of course, is also passive. Another passive is basically gravity. If you can find a way to make the connector oriented vertically so that it drops down into the whatever the receiver device is, you can make gravity work for you.
Yeah, well, two things. Number one, if we're planning on using the standard ones I have at home, none of them point down. And
Yeah, so
number
we're
two,
already, I think, not talking about the standard ones you use at home, because if you want to use any standard USB socket that's randomly available, you need to have at least some manipulator arm type thing that can reach a range of heights and locations, and you basically need to put it on a robot arm. So I think the two
it
extreme
is not the same kind
solutions
of
are
robot
that.
arm.
Hmm?
I said it's not the same kind of robot arm. There's a difference between a robot arm that can go anywhere and push with a pound and a half, and one that can just go anywhere. I'd like to point out that you could have a spring-loaded design that w- when you push it in, when it pushes all the way, it releases a spring in order to lock. And then when you pull it out, it, let's call it, recharges the spring. So you could have, again, it's a fidgety mechanical design, but you could have a USB connector, which is easy to push in and more difficult to to pull out.
Mhm.
And for robots, pulling out is much easier than pushing in.
One idea would be to let these magnetic cables, uh, or one side, let it hang on the robot, like downward
Mhm.
facing, and then have it like and the other part like facing upwards, and then the robot just tries to drive over this, and then the magnets do the job. Like
Yeah, that's
simple.
what I was. That's why I was suggesting vertical. Gravity will work on its own, and yeah, if you add a magnet, it'll be even better capture. But I think there's basically two extreme options here. One is as specialized and simple as possible, and the other is as generalized and sort of like capable as possible. So the other extreme I'm thinking of is if you have a very general purpose manipulator arm and you have like a regular dangling USB dongle type thing, the arm would just grab the USB and put it in. And yeah, Mayor is right about the trade-off. Like manipulator arm that can move all over the place very flexibly will probably have lower pushing power versus one that doesn't have much range of motion will have more pushing pulling power. So that's a trade-off to design. But the once you're designing for general purpose manipulation, you have a reason to like make it more powerful anyway, right? If you wanted to be able to, I don't know, uh, lift and drop stuff, maybe carry a drill and drill into the soil for samples, those are higher power applications. So if you have a range of applications, you can justify more power on the manipulator arm.
You can justify, but it doesn't mean you have a budget for it.
Yeah,
Um,
so you'd increase the battery size. But the nice thing about
uh,
manipulator arms is you want the duty cycle is very spiky. You'll only occasionally use them.
like we don't have to have a robot, we could have some sort of automation too, right? like like a railing in which the robot slides, and then
Oh
after
yeah.
the robot is like grabbed by the rail. It just it pushes the rails, push the robot's USB
Mhm.
inside the socket.
Oh, yeah, that's a clever idea. That's how car washes work in the US. I don't know how they work in Europe and Israel, but in the US, many car washes, you drive into a slot and some kind of like chain like mechanism grabs the car and moves it along.
Yeah, we I put in a link, Anuraj, where somebody has a spring-loaded USB connector, and they solve a different problem, which is which side. It just shows the pictures. Click on View Gallery. Yeah. Okay. So you see they have two white pieces, and whichever one you push in, it automatically aligns. So people, it's important. Imagine the robot trying to plug it in with the last 2% of power, and it's not plugging in, and then it tries to flip it over, and it's still not plugging in.
It's always the
But
third time.
what is this? How does this work?
Here,
But
you
it
just
just
open the relevant window, the relevant picture, where he explains it.
It's a mechanically depolarized connector. So the main connector is polarized, but they've figured out a mechanical way to depolarize it. Stretchy, stretchy layers.
That's a very technical term.
it has connections on both sides.
Yeah.
But overall, my
Okay.
instinct is to not mess with the standardized things as much and mess with things around it. So my ideal solution would leave the USB connectors in the standard forms and figure out something else around it to make the connection.
So yeah, you can have a plug with an optical detector on the plug, or an acoustic detector on the plug, which helps aim it directly into the socket.
No, we don't want that much accuracy, right? The last few should be done like should be automatic, few millimeters.
It's
Yeah.
done
We
by the machine. What do you mean?
like we don't want the robot to do the last millimeters of accuracy. The docking station should do it for it, the robot.
Well, that's the question. Do you have a docking station, or can you connect to any plug? The difference between a robot that can charge anywhere in your house and one that requires you to buy 10 docking stations. So if the docking stations cost $1 each, I don't think it's an issue. Okay, so an adapter magnetic to USB is cheap. But if it's going to be a full-fledged docking station which aligns the robot and so on,
Yeah, that's true. That increases the price a lot. Like yeah, the easiest way we would be to have like a magnetic plug into the USB and then something that dangles downwards.
and but then you have to buy 10 of them for your house. So if it's $1 each, how much does they cost?
Uh, $20.
This is not a trivial thing. Like in the electric vehicles market, the whole thing about like standardizing the chargers, and Tesla has its standard, and then there's the other standard, and now I think Volvo is adapting the Tesla standard. So uh, yeah, this is like a important war zone, standards war. Anyway, yeah, a bunch of good ideas here. But,
I might buy this magnetic stuff and then
Yeah,
check
it's really cute,
if it's
but $20, that's
yeah, that's a little. But you can get it for cheap on like the actual price is not that much. The connectors, so it's like 70 cents.
yeah, I think for initial quick and dirty type solution, it's fine to have like specialized docking station and specialized magnets and whatever. But the eventual solution should either be generic plug with like specialized mechanism or a generalized manipulator.
So you can get like 5 to 10 of these in $1 from AliExpress, I think.
What is this? Oh,
Uh,
you were looking at something else.
yeah.
There's a robot looking thing.
So
If you can get it for like I said, for $1 each, so yeah, it's an easy solution.
The other thing to keep in mind is I think if you're doing rover applications out in the desert or something, you can do whatever custom solution you want because the only charging station out there will probably be your own. If you're doing like domestic or urban sidewalks and stuff, you should probably design for whatever standard is getting popular. Like home automation, Roomba has its charging stations. So the idea, if you think there's going to be other robots that already have charging stations, you should plan to use those.
this is pricier, the induction one
Yes.
that comes with this robot, K robot.
I saw a $20 or $30 charging kit for basically making your own wireless phone
Yeah, I
charger
have
from
one of I
Adafruit.
have yeah, I have those.
Actually, could we just use a standard phone wireless charger? I think we could. Yeah,
Yeah.
that. People usually have like many people have that. I have a couple.
Yeah.
The standard iPhone wireless charger. They're also very flexible. You can leave them lying around on the floor.
But it also requires relatively high accuracy of placement.
Yeah,
No, it
and
has magnets, right? So it slides into place.
oh, not this one. I'm talking about like just a cheap iPhone charger. There, you just have to place the phone on top.
Talking
So in
about
this
something
case, you
like
would,
that,
yeah, I have one
just a
somewhere.
flat piece.
Ranging from 5 watt to 30 watt. Should be
Yeah,
good enough, I guess.
mine is about 2 inches around circle. I'm actually going to. This is going to be my first experiment whenever I eventually get time to actually do something. I haven't been
How
able
do
to
you
do.
connect, or what charging circuit do you use which can work in parallel with charging? In other words, what do I attach to the robot and how do I attach it so I can still use a USB if I want?
Bad for battery health. Hey. Oh yeah, the middle picture over there. That's the one I have for the iPhone.
This
Apple.
one.
Yeah, that's the one I have.
Yeah.
So this is, I think, this kind of thing is the most common. And the other side of that would be, yeah, just an induction coil type thing from Adafruit that you can like you would put on something that you would lower right to make surface contact.
But would they work without any problems?
Well,
I
the
mean,
circuitry is smart. You know
it
what?
goes into an USB power port, so it should. I think it'll be standard 5 volts.
Yeah, it
It's
just works. But what are you going to put on the robot?
the other thing that you can buy from the uh, Adafruit, the corresponding part, I think.
The receiver.
Yeah,
A
this needs some
charging
research.
base.
I think it's just two identical coils or something.
No, but you have circuitry. The coils is easy. You
That
have
I
to have,
think the existing power management circuitry may be able to handle. So long as you can put in roughly 5 volts into the USB port, it'll manage the rest. Anyway,
oh,
I don't
and
know. I'm speculating at this point.
did you know that there was a Type D connector for USB?
No? What does Type D do?
It's like Philips. It's a Philips shape.
I
Oh,
think
Nah,
the
this,
third
I'm sorry,
third.
it's an April Fool's joke, but that would actually be nice.
this should do our job,
Yeah,
right? It's like 5
this is
volt at
what I was thinking
1.3
of. Yeah,
amps. Yeah.
Yeah, look at
this
all
is
the
what I was thinking of.
circuitry over there. What they're holding in their hand, look how many whatevers it has.
So I would put that in like a little heavy weighted block and just lower it right onto the other end with some rough alignment. Even somewhat rough alignment does a fairly good job, I think. Like my iPhone charges, even if I don't exactly place it correctly, it's slower, but it does it. And it can even go through like about 2 millimeter thick rubber casing. So you don't need direct metal to metal contact either. So we
I
are
don't
not
know.
looking for efficiency or high speed charging. We just want charging.
So this exactly like fits our needs, right? And because
Yeah.
it's like we have to charge, it gives out 5 volts, 1 amps.
So
That's why I was suggesting this.
if we had a design, or even better, a hack. I mean, Venkat has at least two of these transmitters at home. If there's a way to take the transmitter, rewire it a little, and attach a USB mini plug to it, and then you just plug it into your tumbler and you're ready to go.
Yeah, basically. So
And we
the
could put it on the tail, the tail of the tumbler. It just
yeah.
drags along on the floor. And when it passes these power points, it goes ching ching and eats the power.
Yeah. So I would have to buy the thing she's holding in her hand. The other end, I think, can just be a
Maybe
standard
not.
phone charger.
Maybe not. That's what I'm saying. Maybe the transmitter with a little bit of rewiring can act as a receiver.
Possibly. I don't understand the electricals of how this works. But yeah, this at the moment looks like the simplest solution to me. Magnetic would be second simplest. Fully mechanical, worth speculating about, but not the first solution I would try for.
So this is the kit we need basically. Universal Qi charger, a receiver module. What
Looks
is
cheap,
the
15
capacity?
bucks.
Output voltage 5 volts. Okay, yeah, this is a little less power, but I think it should work with the iPhone. Yeah, okay, they are charging the lithium ion battery with this.
Now, there's a
This is what.
related. Sorry.
Yeah, go on.
No, I was just going to say there's a related problem. What do you do with your USB cable so it doesn't flop around? So it's possible to make it with magnetic beads along the lens so it self aligns. Let me put a link on there.
I would put the actual receiver on like stiff mechanical guide so that it lowers and raises in a vertical direction, and then just use a short cable and like do simple cable management, like use a zip tie. Yeah. So yes, this solution I think exists at least at tumbler scale. This solution won't work if we have a higher power robot, but for tumbler scale, this will work.
Yeah, and then we don't have to worry about the lithium ion charging circuitry with the tumbler battery because the
Yeah.
battery itself has it.
We've got 15 minutes left. Let's look at those two manipulator arm type thing links that we were looking at in the channel. Kind of curious to
Which
see
one?
that.
The SCARA.
Scara and the one you posted that was like 3D printed or something.
The later boards, right?
Yeah.
That is from Hugging Face.
Oh, okay. So Scala is like a very classic old model, and the reason like everybody knows about it is they teach it in like robotics 101 courses because it's the simplest to analyze mathematically. You can see that the motion is
Yeah.
just in one plane mostly, and then the end effector goes along the z-axis. And if I had to design like the simplest possible manipulator for uh, Tumbler, I would probably do something like that. Just two planar links with maybe two planar gripper on it, because you
Yeah.
can also make it very compact, and I think you could make it work with just yeah, you could. The minimal configuration would require two servo motors. That's it.
Okay, you
Yeah.
still need these belts.
Well,
you,
that's
you you don't
one
need the
way
belts if you
of
use
making it.
a SG90 type small servo at the joint itself.
You can also use cables instead of belts. The question is, are you doing pulling or pushing, in a sense?
3D printed SCARA.
Well,
The other idea I had was instead of a Scara, you could have like two single link arms on both sides, like crab claws, and have like a crab like manipulation capacity, which might be interesting in some ways. But yeah, this robot within some range could pick up a USB cable plug and push it into a wall up to a certain height.
maybe I'm being too optimistic, but let's think about T-Rex, who has these teeny little manipulator arms, and they're good for something. So I'm not suggesting T-Rex needed to plug his tail into a USB socket, but I'm wondering maybe having two little arms as opposed to one sophisticated arm gives you enough for our applications.
Yeah, the
Okay, well,
nice thing about two arms is instead of like having to design one complex gripper, you can put like one hand on each arm and then you have like a really wide range. You can hold like a large light object that's like 2 inches wide because your range of two arms is high, or you can
right.
like grab something small if you bring the hands closer together. So you could have two very simple SCARA type linkages on two ends of the uh, tumbler,
Robot.
and yeah.
But what if you made them smaller? In other words, you were talking before about the tumbler aligning itself with a charging station, and I didn't like that too much, but I'm putting aside my dislike for a second and asking if the tumbler itself provides some of the freedom of movement, can the arms be only the end effector with the tumbler itself acting as an arm?
Yeah, that's what I was suggesting for the purely passive type USB. Like, just put it on like a single beam that's jutting out, and the
Oh,
tumbler acts as the thing. That's the simplest possible manipulator where all the degree of freedom actuation comes from the robot itself. It's limited.
But I'm not talking about for charging. I'm talking about for general use.
Yeah,
I mean, you
even for
would feel,
general use, it's the same problem, right? If you think about degrees of freedom, it's it's got 2 degrees of freedom, but with what are called non-holonomic constraint. The rolling constraint of the wheel means that you can't like arbitrarily position in the 2 degrees of freedom. You have to like back
okay,
up, and it's like parallel parking. Most
yeah,
manipulation activities will be like parallel parking if you use the robot itself as your actuation. But it's possible, yeah. Have you guys seen those old little uh, hand clapping controlled remote controlled cars that had like a caster in the back, so three-wheeled robots? So if you clapped once, it would go backwards and it would turn along an arc, and if you clapped again, it would go forward on a straight line because of the way the caster was aligned. So that's like the
yeah,
super simple but very annoying way to control a vehicle. This would be like that, but for controlling an end effector.
yeah. So you're talking about clap control. I saw remote control cars often like that.
Yeah,
You can go forward or back, and when you go back, it
it
turns.
turns. Yeah. Yeah, I'd be like one configuration that would be interesting is two symmetrically controlled SCARA type arms. So like crab-like claws, but they don't move independently. I- the angles mirror each other, so which means there are some problems. It can only grab along the vehicle's axial center line. It can't grab something off to one side.
That's
But you
okay.
can, yeah, you can redirect the entire robot along a different path, and then you can grab in a different direction. Um, so that's an interesting config.
Yeah, but you need to be more clever than that. I'm not sure how, because we want to be able, maybe in the design stage, to trade off the different types of lack of precision.
Mhm.
So if we get back to the docking station, what we've said was maybe the docking station provides some of the required precision, maybe the electronics do, and maybe the software, which tells you that they're not in line, so it just tries again and again until it manages. So this dividing up of who does what, and if the robot as a body provides part of the degrees of freedom, it's interesting what is the right way to design the robotic manipulator.
Yep.
So basically,
And
what you described as a manipulator, not on wheels, but the whole thing is a manipulator.
yeah, it's like bulldozers and excavators are kind of like that. They have very little lateral degrees of freedom, but
Yes,
in a construction
bulldozers.
site, you move the entire bulldozer back and forth, right? Same thing with the
Yeah,
excavator. The other 2 degrees of freedom that are worth thinking about, but they're strong trade offs. One is using compliant linkages. So basically, rubbery, flexible type arms, because then you can use passive environmental things to like uh, get into different configurations. So arms that can bend, but that means they can exert less force because a lot of the force is taken up in the compliance. That's one thing. The other is, I think I mentioned this a few weeks ago in another brainstorm. You can use the environment itself to passively move some degrees of freedom. So, for example, take my symmetric crab claw type configuration, right? That can be mounted on a platform that rotates but not actuated. So if the robot wants to direct its crab claws in a slightly off axis direction,
right.
it can go bump into a door or something and like rotate the crab claw so it points slightly differently. So more
Okay, that
complicated control.
that's very important what you just said. What you just said was that maybe we get the accuracy of the robot by inanimate external objects.
Yeah.
So what you just said, instead of being able to have the robot turn by 2 degrees, it bumps into a rock, which makes it turn about 2 degrees, and if that wasn't good, you just bump again, until you get
Yeah.
the 2 degrees.
And this is also the logic of things like magnetic last inch or the air-to-air refueling. Like the reason they use all those funnel type mechanisms for like mating is precisely that the bumping forces themselves align everything, right? So you have a funnel shaped receiver on the air-to-air refueling. I think it's on the tanker aircraft, and then the probe of the fighter aircraft that is going in, that's rigid, but it goes into the funnel like thing. And this is another interesting one that won't work for us, but if you know how these tanker aircraft work, they actually have
Hmm.
little wings on them. So there's a guy in the back
Yeah,
literally flying the boom like a plane, but it's passive. It's using wind forces to fly it like a plane, and then the funnel does the last alignment. So the um, fighter pilot will go and like basically shove the probe into the funnel, and the tanker guy will fly the funnel to get it in position first. But yeah, that's a force we don't have because our robot is not moving fast enough to get aerodynamic control forces. But it'll actually work in water, because in water, even very low velocities give you fluid forces to work with.
yeah, but in a
Uh,
robot, sorry,
I was
sorry,
just
Anurag.
thinking, like for the funnel mechanism, you could have this if magnetic stuff as a cable, and then like you could just plug into the funnel, and then like something pulls the plug through the narrow part of the funnel to the contact points.
Yep.
So that is like an easy alignment, uh, like problem solution.
Lots of assembly line belts, if you've seen videos of that, work that way. There's like objects coming in on the conveyor belt that are aligned in all sorts of different ways, but the moment they come to like some sort of a station that does something, an
You
optical
get along.
detector or something will actually detect and turn on motors, and then some whirling discs or something will grab the thing and align it in the right way. So yeah, this is a common technique in reactive manipulation is how I would call it. So the manipulation happens on the receiving end of the operation, and it's triggered by the other passive end coming into the range of action, basically. So this is actually this is a good mechanism because it can be very stupid. Even plants use it, right? Like if you've seen Venus flytrap type plants, they're not animals, but it's got jaws. So when an insect lands inside the Venus flytrap, the jaws of the plant close. It's a reactive
Hmm.
passive manipulator. It's triggered by the thing it's eating.
Yeah,
Like compare that with a frog, right? When a frog tries to catch an insect, it has to watch, it has to track, it has to like shoot its tongue out and grab the insect. Whereas a plant, it just waits for the bug to land on it.
Yeah, much less
that's a
computation
powerful.
required.
Yeah.
Well, I did just buy a carnivorous plant last week, but not a Venus flytrap.
Yeah, it would be fun to have a Venus flytrap type charging mechanism that just grabs any USB cable that comes in and forces it to charge.
Um, what about using gravity to? I mean, we have a tumbler. There's gravity acting on it all the time. We can decide, let's call it how to fall. Just like you were talking about wings for getting airflow. If you move a weight around inside the tumbler, it will lean to the left or to the right, and so on.
Yeah, those mechanisms are used to be quite popular. If you Google proof mass actuators, that's a way of actuating that works by sliding masses around, basically.
Can you
So
say again what it's called?
proof mass actuator. So proof as in mathematical proof, and mass, proof mass actuators. They used to be popular in like rolling robots, underwater robots that move by sliding weights around.
Yeah.
So yeah, it's a difficult control technique, but it can work when gravity is strong.
Well, Tumbler has a long way to fall.
There was there were some really nice underwater robots built at Princeton about 30 years ago that used these things.
But also the modular cubes that we saw use that.
Mhm.
Because they have little flywheels inside and they can hop around.
It's been a long time since I thought of this. Right. Some interesting manipulation choices.
If you have it in the plug itself, that would be interesting. A tiny proof math actuator inside the plug itself, which lets it, hop around and
Yeah, I think I'll take out my Adafruit induction charging kits and then see how long the tumbler battery takes to charge and try to report back.
well, a very
It's
long.
a small powered one, but maybe like for us, like the 1 ampere one would be better to have.
Yeah, I think what we're interested in at this stage is just proof of concept of a charging design. The If we eventually want to do a Yakusar that's capable of field operations, then we'll have to think of things like for every hour of operation, how many minutes of charging does it need, things like that. Then we'll have a duty cycle and stuff. And at some point, we should also have another brainstorm session about solar charging, because you have solar, you have charging station charging, and then you have the battery. You have like basically three power circuits.
Yeah.
All right.
Okay.
Yeah.
Good session today. See you next week.
Yeah.